Okay, welcome to iChem Lesson 6 on covalent bonding and names including acids. So first, a covalent bond. It's a non-metal atom that shares valence electrons with another non-metal atom. Both atoms achieve stability. So unlike ionic bonding, in this case, all the electrons are shared to achieve stability. We'll learn to name these covalent compounds. We'll learn to write the formulas in this video. And then later this week we'll be able to draw these Lewis structures you're seeing here with the dots and X's and so on representing the electrons, and then use those drawings to analyze and predict properties, including how the molecules behave and also what shape they would have. So before we start writing formulas and names, we need to cover some important prefixes. Maybe some of you have seen these before. 1 is mono, 2 is di, 3 is tri, 4 is tetra. Up to this point, these should probably look pretty familiar. The higher numbers get less and less familiar. 5, penta, like pentagon, 5. 6 is hexa. 7 is hepta with a P. 8 is octa. Remember our octet rule needed 8 electrons. There's that prefix again. 9 is nona. And 10 is deca. We will use these when we're writing formulas and naming compounds. So let's start with writing formulas. So the prefixes are used to determine the subscripts for each element. You have to be given, at this point, you have to be given the name to be able to write the formula. You'll have to be pretty proficient in Lewis dot structures to be able to just predict the formula at this point. Okay, so here we have phosphorus trioxide. So we're not crisscrossing or anything like that. We're just looking at the prefixes. There's nothing here in front of phosphorus. In front of oxide, there's a tri. The fact that there's nothing indicates that there's 1. Remember, 1s are typically just implied. The tri means there are 3 oxygens. If we put that all together, we have P with the implied 1, O3. PO3 is phosphorus trioxide. Let's come over here to example 2. I have dinitrogen trioxide. The di means there are 2 nitrogens. The tri means there are 3 oxygens. Put it all together. N2O3. Last one. Tri goes with the carbon. Octa goes with the hydride. 3 carbons. 8 H. Hydrides H. That was kind of a tricky one there. Hydrogen hydride. 8 hydrogens. Put it all together. C3H8. Okay. Now let's do it the other way. Writing the names. So use the subscripts to determine the prefix. The first element is always written out the whole word. The second element should always end in IDE. If you follow these rules, you should be fine. So let's come over to example 1. Look at the subscripts. You have a 2 and a 5. The 5 goes pent. The 2, you can say di, nitrogen, pent, oxide. The di goes with the nitrogen, the pent goes with the oxygen. Dinitrogen, pentoxide. Usually we leave off the like penta, we leave off the A when we're dealing with a element that starts in a vowel. Instead of saying pentaoxide, we just say pentoxide. Okay, let's come over here. We have carbon and fluorine. The subscript on the carbon is the implied 1. The subscript on fluorine is a 4. So the 4 is a tetra, We have the implied one here. With the first element here, we just write out the word carbon. The implied one means we don't have to write anything here. And then with the fluorine, that should say tet with no N there, sorry. Tetra fluoride. Last example. P2O6. Okay, the 6 tells us hexa, the 2 says di, and we go di, phosphorus, hexa with the oxygen, hexaoxide. Okay, so these just take practice over and over, but really what you need to know is you need to know all of your prefixes and you need to apply them. One special case we didn't necessarily talk about is when the second element has a 1. We'll do some examples in class with that tomorrow, but when the second element has a 1, you do need to put something. You can't make it implied anymore. That's when we use the prefix mon. Well, that will come up tomorrow. Okay. All right, so before we move on to acids, I'd like to ask you the secret question of the day, or give you the answer to the secret question of the day. All of this work makes me hungry, so makes me think about candy. My favorite candy is Butterfingers. That might actually be, you know, a hint or a bribe if you're thinking about doing that too. I like Butterfingers. All right, so acids. Acids are compounds that produce a hydrogen ion when they're dissolved in water. This will become much more important towards the end of the semester, but for now you just need to know how to name them. So recognize them by finding the H at the front of the formula. Hydrogen being the cation in all acids. Some examples you see listed here: H2SO4, sulfuric acid, HCl, hydrochloric acid, HNO3, nitric acid, HBr, hydrobromic acid. You may have noticed a pattern in my naming. There were different ways. Some of them I started with hydro and some of them I didn't. That's because there are two types. I have binary acids. Those are the ones that contain a hydrogen bonded to one other element. They do not contain oxygen. And there are oxyacids that contain a hydrogen bonded to a polyatomic ion. So in naming these, for a binary acid, you take the prefix hydro. You put the root of the element, and then you end it in ic, and then the word acid. So here's some examples. HCl, I start with hydro, the root of chlorine is chlor, and then I end it in ic, hydrochloric acid. I have H2S, it's hydro, the element is sulfur, the root sulfur, sulfuric acid. Last one here, I have HI. I have hydro, I is iodine, iodic acid. Okay, so I'm chopping off the end of the element and I'm putting ic, acid. Okay, for the oxyacids, there are a couple of rules you need to remember. If the ion ends in ate, like a sulfate or a phosphate, nitrate, then your acid is going to end in ic. So for example, this is the nitrate ion, it's nitric acid. This is the sulfate ion, so it's sulfuric acid. I have the next set, if it ends in ITE, the polyatomic ion ends in ITE, then acid ends in OUS. So I have HNO2, which is nitrite, so it's nitrous acid. I have H2SO3, which is sulfurite, so it's sulfurous acid. Okay, so that's writing the names. Let's see if we can go from names to formulas. In general, we have to follow our crisscross the ion chart charges, or our swap and drop, as if it was an ionic compound. For binary acids, our example, hydronitric acid. Okay, so ask yourself, if it has a hydro, does it have a hydro? If the answer is yes, then it's no to polyatomic. So I'm just putting the H for hydrogen. The nitric means that it's not a polyatomic, it's a binary acid, so it doesn't contain oxygen, just nitrogen. Swap and drop, H3N. So look for the hydro. If there's a hydro, it means there's no polyatomic and there's no oxygen. So then I just take the H and the element, swap and drop the charges. Okay. Let's do another example and look for our suffixes. Chlorous acid. You'll notice this time I don't have a hydro. So if there's no hydro, yes, it is a polyatomic. So if it's a polyatomic, then I have to look at the suffix here and decide whether it's a polyatomic ion with an ite or an ate. Chlorous, so the suffix OUS tells you that it's an ite ion, ends in ITE. So specifically, OUS, ite ion, in this case, chlorite. So I have to look up on my polyatomic ions. ClO2 minus is chlorite. It's always the cation is hydrogen. Swap and drop the charges. Here it's 1 to 1, so you just have HClO2. All right, so be prepared to practice all of this naming stuff tomorrow. Don't forget, you have a quiz on naming just the ionic compounds that we had been working on all the previous days tomorrow as well. See you tomorrow. Bye.